Talbot Steelworks is undergoing a £1.25 billion investment in low CO2 or green steelmaking, as people call it. Now, the thing that most people will know about that is the change from blast furnace to electric arc furnace technology, which will be based on using scrap steel rather than raw materials brought in from the other side of the world. You may have seen a few weeks ago, I came around the site with Peter Jones, who's the program manager for the melt shop. So everything through from where the scrap's going to come in, where it's going to be laid down, to the arc furnace site itself, and then through to the continuous casters where it's going to be cast into solid slabs. The thing people know less about the 1.25 billion investment, it also includes some investment in those parts of the processes that do something with that slab steel. So they roll it into usable material and coils. And that is the mills program. And I think it's important that people understand that that is also part of the investment, and that having an arc furnace alone will not on itself secure a sustainable site here and a sustainable UK steel industry. So we've come down today to the hot rolling mill here in Talbot, and delighted to be joined by Andrew McGregor. Andrew, you're program manager for the mills part of the investment program. Why is it so important to also spend money on these downstream assets as well as just the arc furnace?
A number of our downstream assets are also at the end of their lives. So key components of the hot strip mill, the crop shear and the coil box, they won't last. So if we haven't got a crop shear and a coil box, we haven't got a hot mill operation, we haven't got a sustainable business.
Yeah.
So it's important that as part of this program, these key elements of the hot mill are replaced with new equipment, up-to-date equipment that allows the hot mill to have another 10 to 15 years worth of rolling while we build up the sustainability of the site. We become profitable on the back of the AF to allow further investment. But without this investment now in the hot mill, we'll never be profitable in the long term. We'll never be able to generate the revenue to invest in the bigger pictures that we need to do to get a full-term sustainable business here.
Yeah, because I think people who know the business will be aware that the hot mill is kind of the bottleneck unit. It's limited in its capacity, but also that pretty much every product that goes to Trostre, Corby, Hartlepool, Wensfield, Llanwern starts its life here in the hot mill. So this place behind us is absolutely critical, isn't it?
Absolutely fundamental to the operation. Without the hot mill, we don't have a business. And that's all of our downstream businesses as well. So as you say, everything is going through the hot mill.
And I know we're going on to see the Pickle Line a bit later, which is part of the cold rolling products. That's a massive investment in itself, isn't it?
That is a massive investment. So our current Pickle Line is at the end of its life. Operationally, it's very expensive to run at the moment. So as part of this Invictus program, it's been a massive investment on a new Pickle Line, which will increase the capacity to try and future-proof the site. So the line will have a capacity larger than we can currently make the most of. Have a 1.8 million tonne capacity, and that's to allow for future expansion. We're not quite sure which way the markets will go in the future, but this new Pickle Line will allow the cold mill to roll more if investment is put into the cold mill, or to expand the pickle and oil market. So it's really an enabler, not only to replace our end-of-life Pickle Line, but an enabler for the future in terms of different directions the markets can go in to make sure that we really are a sustainable site for the next 20, 25 years.
Yeah, and I don't know if you feel it's like a curse or a blessing, but actually it's kind of falling under the radar a bit, isn't it?
But yeah, I mean, the Mills programme, that's as big an investment as Blast Furnace 4, the biggest project that we've done on this site. But you're absolutely right, we fly under the radar. It is a massive project, it is a massive challenge, but in light of the AAF challenge, it is dwarfed by it in some regards. On the same grounds, we get the benefit of going on the back of that project. The project systems put in place for this huge investment run across the whole of the Invictus programme. So it really is a real step forwards for the mills as well as the heavy end.
Yeah, and I'm really grateful for you spending some time with us today, because we're going to walk through some of these places so that people can see them firsthand and get an understanding of them. The first place we're going to go is the hot strip mill, and hopefully they'll be rolling and we'll see some nice hot metal in there, and we're going to talk about the coil box and the crop shear. Can we go in?
Yes, of course.
Great, thanks.
We're at the coil box on the hot strip mill. The coil box enables the product quality to meet the standards we need, because by coiling the coil at this point, it retains the heat while the last coil is going out of the hot mill. So it allows the quality of the product to be maintained, enabling us to get it through the hot mill, and also the throughput. So the coil is coiled here, it's held here to allow the last coil to leave the finishing mill, and then this is fed through into the finishing mill. You'll see that it's being coiled, it's now uncoiling, feeds through into the crop shear, cuts off the fishtail or the head end of the coil to remove that area, ready to go through the finishing mill. Without that, you can't prep the coil to go into the finishing mill. You can't roll. Without the coil box, you don't retain the heat in the coil to allow it to get through the finishing mill, particularly at the tonnages that the mill needs to run at with the new electric arc furnace.
So it's absolutely fundamental for the mill. And without the coil box, you couldn't produce many of the products we currently make. Is that true?
It's very limited on the products that we can produce without the coil box. But without the crop shear, we can't produce any, because you have to prep the coil.
So two separate units. They look massive pieces of engineering. Are you going to be changing bits of it, or are you going to be changing all of it?
All of it. Both pieces completely come out. So we completely remove the entire coil box and the crop shear and the drive systems. So a lot of the work we're doing at the moment is to prep ready prior to the shutdown to install it. All the new drives have to be put in place, all the control systems, the pipework, the hydraulics, all ready so that in the 22-day shutdown, we actually can go in and change the coil box and crop shear. There's some big challenges around it. The units have to come out there heavier than the cranes, so they have to be taken out in modules, and we're going to pre-build the new sections to go in modules, and hopefully then lower them in. Only when we've taken out the existing crop shear and coil box will we be able to properly assess the foundations underneath. There's work we can do up front to get new foundations, there's modifications to the foundations, but the actual foundation under them, we'll only know when the coil box comes out.
Yeah, and I know I was lucky enough to come up a few weeks ago and meet some of the project team, and they talked about the extent of it, because I thought, it's just that bit, but they're talking about cellars, they're talking about hydraulics, they're talking about the electronics, all the cellars under the mill. There's a huge amount of sort of infrastructure work going on around it.
There is. So the biggest challenge around that is it's fitting into our existing infrastructure. So some of the real challenges we've been trying to work our way through, we need to put in new foundation support, which either means moving hundreds of cables or trying to work with our civil designers to innovatively work how you can put new foundation supports in without affecting the cables, how we can reroute pipe work. All the real challenges around that, if you imagine we've got, there's thousands of data network cables as well as the actuators. One cable, but there like to be 40 control cables running through it. Moving those cables could have an effect on the ongoing operation of the hot mills. So if we have to recommission them every time we move a cable, any delay, any one pair of cables not connected correctly will cause downtime on the asset that is running, keep us profitable while the electric arc furnace is being built. But it's a real challenge to minimise the risk of the project work on the operation, but also to get the hot mill ready for the new equipment to go in with the cabling, the hydraulics, the services. That's the real challenge here, to get everything in place.
I think it is unlike any other part of the programme, because, as you explained there, the current business model of importing plants, heating them up and rolling in a hot mill depends on having a hot mill running. So you're kind of building a plane while you're flying it, sort of thing, aren't you? When's all this work going to take place, Andrew?
We're currently still in the contract negotiations. It's about 18 months for the supply of the equipment from the point when we sign the contract, which hopefully should be very soon now. So it will then depend on the exact production requirements as to when we've got that. But it's about 18 months from the point of signing the contract.
Effectively, you're going to try and do all of this work. I know there's lots of preparatory work that can go on in the meantime, but all of the work to replace these two massive units is going to be an extended maintenance stop, arguably, is it?
Yes, it's going to be a massive change. And the new coil box, this current coil box was put in the 1980s. Technology has moved forward. This coil box has been modified numerous times. It's been really reliable, but it's also come to the end of its life. It's been refurbished and refurbished and refurbished to a point you just can't really refurbish it anymore. So that's why it's seen as part of the Invictus project. Without it, we can't run. It's fundamental to us being a sustainable business. And the same with the crop shear. The crop shear put in again around the same time. It's at the end of its life. We can't refurbish these anymore. They're real risks to the current operation. We need to replace them. And of course, the product that comes off this mill is a hot rolled coil. And that hot rolled coil goes somewhere, doesn't it? And it goes to... Well, yeah, we have two different routes for hot rolled coil. So a number of our hot rolled coil goes out as hot rolled coil through the skid park mill. The rest goes to the pickle line and ready for cold rolling and our downstream operations, which I think is where you're going to take us next.
Yeah, let's go there then. Nice one, thanks. So Andrew, we've come to what is known as Pickle Alley. Tell us what's going on here and where we are in relation to the rest of the plant.
So we have hot sheet finishing on our left, and on our right we have the pickle line and the entry to the pickle line. Directly in front of us, and you'll be able to see in a few minutes on the camera, we have the coil transfer from hot sheet finishing across to the quench, and we'll go and have a look at that in a minute. But the reason I thought it'd be good to come here is to look at the very unexciting buildings directly behind you. So we have what is currently, or was currently, the Pickle Line office facility, and next to it the mechanical workshop. Nothing very exciting to see here. What we're going to do is flatten it.
Oh, nice.
So these buildings have been emptied, vacated. All of this is being flattened.
Yeah.
It's being taken away. And what we plan to do is build a new acid recovery plant here. So we're in the early stages of discussions with suppliers, trying to get tentative information. So we can get planning permission. This is one of the key parts of the Invictus Mills program that needs planning permission.
Yeah.
Most of the work we're doing in the mills is within the existing infrastructure. This section is a new building. We haven't had an acid recovery plant in Port Talbot for some 40 years plus.
Wow.
The advantage of an acid recovery plant is it allows you to recover the used hydrochloric acid, the spent liquor, as we call it, from the pickle line. Currently, we dispose of our spent liquor. It's sold, it's reused in other areas and different businesses.
Yeah, so the acid recovery plant is going to go along here. In terms of our existing pickle line, is that just behind here? And then where's the new one going? Is that
The bay over.
The bay over, and I know we're going to go in there a minute. So the first process of the hot roll coil coming across from the hot mill is that quenching process. Can we go and have a look at that and what's going to happen to that?
Yeah.
Perfect.
Here we have the coils. You can see these are coming across from hot sheet finishing. You can feel the heat radiating off these coils. They're too hot to process. These couldn't go into the pickle line now. One, they melt some of the equipment to handle them, so the guide rollers and things like that can't take the heat of these coils.
Yeah.
Not to mention, we'd be evaporating so much acid out, putting coils at this temperature into the line.
Yeah.
So these coils, either you let them cool naturally, which takes about 7 days.
Wow.
So then you'd have 7 days worth of product cooling, and that's a vast amount of money to have tied up in the process. Or, as we do, you quench them. So these coils go into the entry to the cold mill area, to the quench area.
Yeah.
They're loaded into large tanks, which are then filled with water, quenched for the duration of the largest coil of the batch, and then the water's drained, the coils are taken out and put into stock, ready to be scheduled for the pickle line.
Wow. Does that not affect the metallurgical properties of the steel, quenching them so quickly?
No, because we're already below the key temperatures. Those metallurgical properties are set on the run-out tables of the hot strip mill.
Okay. Wow. That's a hell of a process, isn't it? But I understand that's all going to change.
It is going to change. So, as I've just described, the current process is a batch process.
Yes.
We had some real problems with the orientation, how we're going to feed coils into the new pickle line.
Yeah.
So as I've said, the coils currently go into the batch and then they go down the bay into the existing pickle line.
Yeah.
In the new process, they're going to, instead of going this way down into the ground, they're going to go this way.
Okay.
But the end of the building is just over there.
Right, okay.
We need about 9,000 tons of coil in front of the pickle line to allow it to be scheduled. Otherwise, it's just too hard to manoeuvre coils around. And currently, with the current configuration, we've got capacity for about 3,000 tons.
Wow.
That's quite a difference. We looked at moving the quench tanks, building new quench tanks further down because we're going to have a large area in the existing pickle bay which won't be being needed. So there's plenty of room to do that. We're going to put in automated cranes, which we think will improve the process. It'll speed up the process. The crane drivers who currently operate this, they have a real challenge to keep up with the hot mill when it's on full production. It's virtually impossible. We're also going to change from tongs, which currently we use to move the coils around, to magnets. And the advantage of that is tongs have to open and close, which means you can't put a coil right next to a coil. Magnets come down on top. You don't have to have any gap between them. You can put coils closer to each other. So by changing to automated cranes, by changing to magnets, it allows you to get more capacity in the same area. But that still doesn't give us the 9,000 tons we want. So we're going to extend the bay by some 25 metres. And those together give us the capacity that we need to schedule the new pickle line, while also automating it, making sure you'll find when these coils are labelled, they go into a big bath of water, the labels come off, it becomes hard to track coils. So this system being automated, the coil coming off the hot mill will be tracked in the computer system from the hot mill all the way through the quench onto the pickle line, taking away any errors, any loss of signatures, etc.
And weren't you telling me earlier that instead of that whole batch process where you leave them on as long as the biggest coil, the new system will effectively judge each coil on its own merit and leave it in as only as long as it needs to, so it's more efficient as well?
Absolutely. The current batch quench system, the crane drivers can't see where the bases are when the tanks are full of water. So you have to drain the tanks, put in your 25 coils, then fill it up with water. The crane isn't relying on seeing it, it's relying on coordinates to know where it is. So the tank can be left full of water, the coil can be lowered into a full tank of water. As a result, we can measure the temperature of that coil at the point it goes into the water, determine how long it needs to stay in there, and then take it out. That allows, one, a faster throughput, but two, it also means that a coil can be scheduled directly from the quench tank onto the new pickle line, reducing the amount of storage you need to schedule the line, because the quench tank's in effect become part of your storage.
Okay. What's the next bit of the process we ought to go and see then? Is it the extension where the quench tanks process is going, and then maybe the bay where you're going to build the new pickle line?
If we go and have a quick look at the quench tanks, I can show you then where the new entry line is going to be goes through the wall into the batch annealing bay, and then we'll go over to the batch annealing bay.
Great, let's do that. Thanks.
You can see the coils are coming out of the quench tanks at the moment. There are 5 quench tanks here. We use 4 at any one time. Once the coils have been quenched, they're taken out, put into stock, ready to go on to the pickle line, which is down in this bay. If we head further up, I'll show you where the coils will, instead of going this way, they'll go up the bay. So we're now at the end of the pickle bay. We're at the quench end of it. You can see the end of the building. You can see we have a small stocking area here. This isn't sufficient to schedule the new pickle line. You can see that we have to keep gaps between the coils to allow the tongs to work. But it's at this point, there'll be the walking beam conveyor going through that wall into the bay next door, which is the old batch annealing bay. This is the feed to the new pickle line here. So the coils that are stored here can't be stored here because we have a walking beam here. So we've already taken out a substantial amount of the storage area. And it's for that reason we'll extend this building 25 meters this way. which will allow us to increase the storage. And then by taking down the gap between the coils through the use of magnets, allows us to get the amount of coil that we need to schedule the line.
So the quench tanks remain,
Quench tanks will remain.
but with different technology, different cranes, then they're going to be brought to this end before going through to the new pickle line there.
This area will be a closed area.
Yeah.
The automated cranes will be able to pick up coils, feed them through, but the area will be closed to pedestrians, so there'll be security gates so that if you do need to go in for maintenance, which clearly we will, that'll kill the cranes, etc.
So the current pickle line is directly down there as we look at
Directly
it,
down there.
and the new one is going to be next door.
The
so
next bay
you
over.
build it while the current one's operating. Right. Let's go through and have a look at the batch anneal bay, which is where the new pickle line's going to go, because there's already work going on there, isn't there?
Yes.
Great. So Andrew, we've just come into the most gigantic bay, which is the old batch anneal bay.
That's right.
And this is right next door to the bay we were just stood in, which is the current pickle line. And you were saying then that in the future the coils are going to come through the wall. Where's that wall?
That's that wall over there,
Yeah.
column Y65.
Yeah.
There's still a little bit of whether it's this one or that one, but that's in the basic engineering at the moment.
Yeah.
But it's in this area. Coils will come through the wall. So the quench tanks on the other side up here.
Yeah.
The coil storage we were standing in
Yeah.
literally a couple of minutes ago,
Yeah.
just on the other side of the wall there. Coils will come in across here to the entry part of the new pickle line. So there'll be two payoff reels here leading through into the entry systems, the accumulator, the laser welder, and off and into the system.
So before we go on to the new pickle line, this is the most enormous bay, isn't it? It feels like you'd land an aircraft in here.
Yeah.
But before we go on to the new pickle line, explain to me what's been in here, currently in here, and what preparatory work you're having to do in here before you even put a spade in the ground for the new stuff.
This is the old batch annealing bay, as we said earlier, and there's a mixture of equipment in here. A large percentage, 80-odd% of the equipment is dead.
Yeah.
When the Capel was built and commissioned, most of the annealing bases in here, the multi-stack annealing bases, became redundant.
Yeah.
And they were decommissioned at that time. The only bit which was left was the Ebner bases, which is just behind us here.
Yeah.
This section was live until March this year.
Wow.
With the mothballing of the Capel line, the closure of the Ebner batch annealing was also done. They only were there to feed the small amount of the market that couldn't be processed through the Capel line.
Yeah.
So this has been decommissioned. That's the only part that was left live. Everything else in this bay is derelict.
Yeah.
It was decommissioned in the past, but it was done I think 30, 40 years ago. I'm not sure exactly when. But the decommissioning documents are of that time. They're not to the modern standard.
Yeah. Yeah.
We've got real challenges in terms of we've got live cables running through cable runs, which have got multiple dead cables on it.
Nice.
There's asbestos in amongst the rubble on the floor. There's asbestos in the equipment. There's a whole host of challenges around it. Our biggest problem is getting this bay into a fit state that we can bring in machines to do the demolition, and we can't do that while there's any asbestos here.
Of course, and you've got different levels here. You know, you kind of look over the railings and you're kind of going down 20 or 30 feet, and we're standing on a floor which seems very solid, but you kind of think, well, where's this pickle line going to be built? Is it going to be built at this level or that level, or do you need both levels for things like accumulate?
But we're going to be basically building the new pickle line on the cellar level.
Yeah.
So the floor we're standing on at the moment is going to be demolished.
Right.
All the way through down to the current entry accumulator to the current 5-stand mill.
Yeah, and the 5-stand is the cold rolling mill. We
Yes,
call it
that's
five stand. But
So all of this runway and road that we see here will be demolished. All the equipment underneath will be demolished.
Yeah.
First thing is to make sure all the diversions are done, because we can't affect the cold mill.
Yep.
All the electrical diversions, the liquid diversions, all of this needs to be rerouted. The cut lines are almost agreed. There's a final meeting next week with Clesim ABB to agree the final cut line. But then once that's agreed, that'll be marked up in here, and all of this will be taken out by heavy machinery, making sure that key assets such as the power that's still remaining live. We've got fire pumps just over here, which feed the current mill, so we have to work around those. So all of this will be taken out. We're taking out some stuff that should have come out yonks ago. So you see the flues which are dead. Some of these have posed some safety hazards in terms of the supports. Some are beginning to go. All of this will be removed.
It is quite overwhelming, I have to be honest with you, because, you know, for those of you listening to the podcast rather than watching on video, it is difficult to describe the scale of this bay. And when I said a plane could land in here, it does feel a bit like that. Andrew, what I'm going to ask you to do before we finish for today is maybe as if we just walk down the bay and you can kind of describe what the Pickle Line process, what will happen at each stage as we walk down the bay to help people understand what a new Pickle Line looks like and does, and then maybe just as far as the point it joins the 5 stand.
It's around this area, so we have there's a culvert underneath here. Main electrical supplies run through here, so it's just after this, in this section, that the new laser welder will be fitted.
And that weld the tail end of one coil to
the head end of the next one.
coil.
So we end up with a continuous strip of steel. And that laser welder allows us to weld all kinds of different grades of steels, much more than the flash butt welder can. So again, we may not be able to roll them at the moment because we haven't necessarily developed them. But as the electric arc process improves, as we get to the point where we're pushing the boundaries of things and trying to make sure that we are future-proof, that laser welder should be able to cope with all the different grades that are seen foreseeable anyway in the next 25 years. So that'll be here. You then have the coil come on and go into the entry accumulator for the Pickle Line. So the accumulator will run along this section.
So it's a horizontal accumulator.
Horizontal accumulator.
And the purpose of that is so you can stop the coil to weld it whilst the coil in the process continues through.
That's correct.
So you build up a lot of material in the accumulator, and as soon as you stop for the weld, it continues at one end and is stationary at the other.
Yeah, so 650 meters long, 6-strand,
Wow.
6-strand accumulator. So it's a vast amount of material. It's as big as we could get it to give us as good operational parameters as we could have. It also allows, if there's a snag on the line, then that we can work our way around that as well. It gives the operators a chance. And then above that, you'll have the pickle tanks. So the pickle tanks will be at the top.
Oh, okay.
They'll be running along here. And there's 4 acid tanks and then 2 rinse tanks. And then after the coil leaves those, it'll come down. You have a choice then. It'll go through inspection systems and there'll be an inspection pulpit. But then we have the choice to either divert the coil at that point to the down coiler.
Right.
So we can pickle and oil it and coil it. So you have a product coming off the pickle line, pickled and oiled coil. Or it'll carry on through and enter into the current mill entry accumulator. And to do that, the strip will run over the top of the current mill accumulator and go in at the far end and then go into the process.
Okay, because currrlently in Talbot, the cold roll products facility, the Pickle Line cold mill, is called Link because the two are linked together.
That's correct.
And in Llanwern, that wasn't the case. They were separate processes, weren't they, between the Pickle Line? But that link required, let's call it a dog leg, but a 90-degree turn in the strip, didn't it? It was quite an incredible thing to see. Now you've moved the Pickle Line across, is that turn not necessary now?
No, that turn is still necessary. We're actually putting another dog leg in.
Right, okay.
Which we tried very hard to avoid, but we had to balance the practicalities of how you fit the new line into this bay and the operator interface to it. So we wanted to move the line slightly away from the columns on that side to allow us to have the high hazard acid tanks, so where the acid from the pickling tanks is returned to a tank. And you need to wear acid-proof PPE for that, which is difficult for the operators. If we had the acid tanks on the front side of the line, then they'd always have to wear that every time you go out for anything, which is not ideal. It also means that you're putting the hazard closer to where people are going to be. So it just, from a health and safety perspective, it's not the right thing to do. So as a result, we need to do a small dog leg back to kick the strip back over to join it and line up with the centre line of the existing mill entry accumulator.
So this is, I know we've kind of walked quite a distance already, but this is still part of the accumulator, and the acid tanks will come out of this.
Yeah.
So it comes out the acid tanks, it comes out the rinse tanks. As you said, there's a down coiler where it can be taken off. There's presumably some sort of oiling process as part of the line here, is there? For pickled on oil product.
You've got an exit accumulator as well from the pickle line before you go into it.
Because you've got to cut the weld out.
Yes.
Of course you have, yeah. And then, I guess in the far distance, and we won't be able to walk through all the way, is the 5 stand and the cold rolling facility.
Yeah, so you can see from here the start of the entry accumulator to the mill, and there's a brick building just to the right.
Yeah.
It's just before that is where we would have the down coiler.
Yeah.
So that would be for the pickled oil to come off. So you've got the pickle and oil facility to put oil on it first, and then it comes off there. Or the strip carries on through the dog leg into the existing accumulator, goes through that, takes its 90-degree turn into the link mill.
And of course, much like we were talking about in the hot mill, that 5 stand and cold rolling facility is going to run throughout the period of investment. And at some stage, you're going to have to link the two together, aren't you?
We are. But we have an advantage. So again, it's the same challenges, but not as pronounced as we've just been discussing about in the hot strip mill. Hot strip mill has to run. The current pickle line, much as it's a difficult operation, it is at the end of its life, it has to run.
Yes.
But we're building the new pickle line in a bay that's derelict in effect. It's full of equipment that's gone or going.
Yeah.
So we can build and commission this line on pickled and oil before we link to the existing mill. So we will run for a period of about 3 months commissioning on pickled and oiled, proving the reliability of the line, so that when we link to the mill, we've got confidence that the line will run. We'll have ironed out the teething issues, no doubt there will be there, and have a good, reliable line that will be able to then link straight through to the mill and hopefully resume production very quickly.
Listen, Andrew, we're going to call it a day because I think we've kind of talked as much as we have time for today about the mills program as part of the Invictus. I think, you know, what is patently obvious from the discussion we've had today is the massive extent and scope of this project that has gone largely unmentioned in the wider scheme of decarbonising the Talbot Steelworks, but the criticality of the project and the complexities of trying to put stuff in place while still operating alongside it, the hot and roll cold rolling facility. So listen, we're going to be following the programme over the next few years with massive interest and trying to pick up some of those details you've talked about today. But for the time being, thanks for giving us the overview. Do keep in touch when milestones are happening and let us know when there's some interesting stuff to come and see. And I'm sure that will be picking up really, really quickly. And all power to your elbow and you and your team for making this happen between now and 2027, 2028.
Excellent. Thank you very much.
Thanks, Andrew. Thanks very much.